The goal of this project was to create an injection molder to recycle waste plastics. In order to complete this, we decided that there were 4 main objectives that would define our success. The first being that the plastics must be sufficiently melted to a form that was more malleable. It also needed to be compatible with commonly recycled plastics. It must generate enough melted material to produce a usable product and function reasonably quick. Over the course of our design process, we determined some constraints. These included cost, time, power, melting temperature, size and weight, and production speed. The cost was determined to be $240. This would later dictate what materials we could use and parts we could buy. The time constraint was limited to the amount of time we can put into the project over the course of the semester. Our power constraint was that of a standard outlet. The melting temperature had to be compatible with multiple types of plastic. This would include HDPE, PET, LDPE, and PP. This gave us a temperature range of about 200 to 280 degrees Celsius. Because the design had to be desktop size, we determined that the weight overall should be approximately 30 pounds. And finally, production speed. A run time of 20 minutes to melt the plastic and fill the mold was deemed appropriate. The final design was able to fulfill many of our constraints. Starting with the cost, it ended up being $186.63. This is well below our budget of $240, but does not include any of the parts that we brought from home. Also, we were able to complete this project in the allotted time and had a fully functioning prototype by the end of the semester. Due to the fact that no fuses were broken during our experiments, it is safe to assume that we have fulfilled our power constraints of using a standard outlet. Our temperature was able to successfully meet the range of 200 to 280 degrees Celsius. However, during any of our injection tests, we would stick to about 240 degrees Celsius. The size of our prototype was very satisfactory. The weight, on the other hand, was a little bit heavier than previously hoped. This is mostly due to the bottle jack. In terms of production speed, it took a little bit longer than 20 minutes to fully inject the plastic. However, we tended to wait longer to make sure that the plastic was fully melted. Future iterations of the injection mold would include the following changes: integrating a way to heat the mold, fine-tuning the amount of plastic and number of jack pumps used to inject the plastic, decreasing the amount of time between injections, and creating an enclosure for the electrical components.
Just like separate it out. It works.
Perfect. That's really cool. But they work.
Glad that worked.
They do work?
Yeah.
You play with it?
Yeah.
There, we got some group sanding video. Wonderful.
I'm not a part of it.